everyone, welcome to another series of the MCA physics class. In today's class we'll be talking about electric cells. Electric current is simply electric charge in motion. In a solid conductor such as wire, the current consists of swarm of moving electrons. Electric currents are chemical devices which are capable of causing an electric current flow. They do this by producing an electric force which pushes the current along. A current will flow only if there is a complete circuit of conductors by which the current can leave from one end or terminal of the cell and travel around the other terminal. The current is the same at any point round the circuit, and if the line of the conductor is broken at any point, the current is switched off and stops. One thing needs to be remembered about electrical circuits. They are negatively charged and flow around the circuit from the negative terminal or cathode of the cell to the positive terminal or anode. So this is the diagram for current flow and electron flow. This is the circuit. You can see the circuit. This is the conventional current flow. This is the electron flow. This is where the current is flowing from, and this is where the electron is coming from. Let's talk about the types of electric cells we have in physics. Cell may be divided into two main kinds. We have the primary cell and the secondary cell. One, primary cell. Primary cells are those cells which cannot be recharged when it has run down. Example is the Leclanché cell. The Leclanché cell is divided into two. We have the wet and dry Leclanché cell. And the other example is the Daniell cell. What you can see on the board is the diagram for the examples that we just stated for the primary cells. The first diagram you have here is the Leclanché cell. The Leclanché cell. This is the wet Leclanché cell. This is the zinc rod. This is the glass vessel. This is the porous pot. And this is the embedded carbon rod. This is your MnO2 and charcoal powder, and this is your ammonium chloride solution. Now this is the dry Leclanché cell. This is the zinc, okay? This is your carbon, and this is your glass. This is the aqueous solution of ammonium chloride. This is a porous earthenware pot. This is the powdered manganese dioxide and granulated carbon. And this is your Daniell cell. The Daniell cell has two poles, which is the cathode and the anode. The cathode is the positive pole. The anode is the negative pole. This is the what? This is the salt bridge where liquid solutions are being transferred, where there's a movement of liquid from one medium to another. And of course, the oxidation takes place here. Electron leaves the anode, electrons enters into the cathode, so it gains electron. Copper 2 plus aqueous plus 2E minus, giving you copper solid. So that's reduction reaction which takes place at the cathode, and this is the oxidation reaction which takes place at the anode. So this is the oxidation. Zinc solid changes to what? Zn minus aqueous, loses 2 electrons, so you have this. So this is exactly what happens. This is what we call ion exchange takes place here at the salt bridge. So that's the ion exchange. And now this is the voltmeter where the voltage is being read. This is what we call the Daniell cell. Alright, now let's talk about the secondary cell. The secondary cell are those cells which can be recharged when it has run down or when it has been used. E.g., we have the lead acid accumulators and the knife accumulator or alkaline accumulator. Okay, so let's see examples of secondary cells. Alright, so this is exactly what we are talking about here. We gave two examples of secondary cells, which is the lead acid accumulator and the alkaline what? Accumulator. So the first one here is the lead acid accumulator. This is the first one. This is what we call the lead acid accumulator. And of course, the second one is the what? Alkaline accumulator. Alkaline accumulator. That's what you're seeing on the board. So that's basically what we have on the board. So the diagrams differ. They are different. They are not the same. As you can see, the diagram already will explain to you how they look like. You know the difference between a lead acid accumulator. Now, a lead acid accumulator is made up of lead. Lead is just what we call Pb. That's the symbol for lead. So it is made of lead. And of course, your alkaline is gotten from your base. So it's made up of base, alkaline. That's like your potassium hydroxide. You can see it's made up of potassium hydroxide, zinc powder with potassium hydroxide. That's what it functions with. So that's why they call it alkaline accumulator. So that's exactly what we mean by lead acid accumulator and alkaline accumulators.